Good morning, class. Welcome to St.PETERS School. So this is your science class, and in previous class we were covered the topic what is Newton's first law of motion, and we also discussed about the what is balanced force and what is unbalanced force. So now today we are going to discuss about the Newton's second law. So before starting the Newton's second law, first of all we need to understand what is momentum. So all the students are requested to please take out your books and take out page number 13. Okay, so on page number 13, you will see the term momentum is written here. Just give a reading to it. Momentum is the product of mass and velocity of an object that is called momentum. Okay, so what is momentum? Momentum is nothing, it's a product of mass and velocity. Mass, weight of the body is known as mass, and velocity, with the speed, by this, with the speed, body displaced from one place to another place, that is called velocity. Okay. So start reading the point. Before discussing about second law of motion, we shall first learn about the momentum of a moving object. Okay, so from our daily life experience, like during the game of table tennis, if the ball hits a player, it does not hurt him. Okay, so what happened in daily life, like the game of the table tennis? You have most of you have seen might be a game of table tennis, or you might have seen in the TV that how to play the table tennis. It's a very small size ball, and a person has to hit that ball with a very small racket, right? So table tennis, if the ball hits a player, it does not hurt him. What happened when the ball sometimes mistakenly hit the person, it doesn't hurt him? Why on the other hand, when a fast moving cricket ball hits a spectator, it may hurt him? While in the when you will see like most of the time it happens, like most of the time our cricket man used to get hurt by the very fast ball coming, right? So it usually happens. Then why why it happens? So because and by the tennis table, tennis ball, nobody get hurts, while by the cricket ball, anybody can hurt easily. So why this happen? Because we all know that the mass of the tennis ball is lighter than the mass of the cricket ball. So this suggests that the impact produced by the moving object depends on both their mass and the velocity. So there appears to exist some quantity of importance that combines the object's mass and its velocity called momentum, and was introduced by Newton. And also it happens, we know that table tennis is a very smaller area, so it is coming from very smaller area. So then that is also the reason why it doesn't hurt, while the cricket ball is coming from the very long distance, right? You might have seen that cricket, the bowler always goes very back, and then from there he started running, and then he used to throw the ball. So why? Because when he covers a long distance, what happened, it covers a more force. He can throw the ball by the more force. हमेशा क्या होता है, आप देखते होगे जो क्रिकेटर में जो बॉल फेंकता है वो हमेशा पीछे जा करके रन करके एंड देन बॉल को थ्रो करता है. व्हाई? बिकॉज ज़्यादा डिस्टेंस लेकर के वो ज़्यादा फोर्स से बॉल को फेंकना चाहता है. वाइल टेबल टेनिस में स्मॉलर एरिया, एंड सो स्मॉलर एरिया में बहुत ज़्यादा फोर्स से बॉल नहीं मारते, दैट्स व्हाई इट डजंट हर्ट. So that is only in this way we understood that for the force or the for the pressure, क्या होता है requirement, both the mass and as well as the velocity. If there's something is coming with a very large velocity, it will have a more impact, it will have a more force on the body. Okay. So momentum can be defined as a mass in motion. All objects have mass. So if an object is moving, then it has a momentum. It has its mass in motion. So that type of body which is coming with a velocity, and it's having a very it is having a mass also. Then that type of body is what we can calculate. We can calculate the momentum of the body. That and what how can we calculate the momentum of that particular body? By taking out the product of mass on the mass of that body, particular object, moving object, into you will multiply with the by the velocity which that body is moving. Okay, so the momentum is is signified as a p. मोमेंटम को हमेशा हम p, स्मॉलर p के फॉर्म में लिखते हैं. So whenever we have to calculate the momentum of the body, first of all we will write p. So wherever you will write see the right p in the question, you will understand that this is the momentum of the body. P of an object is defined as the product of its mass and the velocity. So momentum or the p is equal to mv. Momentum has both direction and magnitude, so it is a vector quantity. Its direction is the same as that the velocity. The SI unit of momentum is kilogram meter per second, kg meter per second. This is the SI unit. This is very important for every term. You should know what is the what which type of which type of quantity is it, it is a scalar or vector, or you must know about the what is the SI and CGS unit of that particular term. Since the application of an unbalanced force brings a change in the velocity of an of the it is therefore clear that the force also produces a change of momentum. We define the momentum at the start of the time interval is the initial momentum, and at the end of the time interval is the final momentum. When the object moves, then it gains a momentum as the velocity increases. Hence, the greater the velocity, greater in the momentum. Okay. So what do you understand by this? Like there is a the body is moving with some initial velocity, some final velocity, that is called unbalanced force. जैसे कि slowly bodies move from like a higher force, and again later on the body is moved by the lower force. So what happens? There is a different types of force, and different types of force means there is a different types of mass also. There is a different types of velocity also by the which the body is moving, so that is called change in momentum. So we can also calculate, we can sometimes we need to take a initial momentum of the body and final momentum of the body, as because and we all know that p is equal to mv. P is equal to mb, momentum is equal to mass into velocity. So always remember, momentum is directly proportional to mv. जब भी ऐसा equation आता है, it means momentum and velocity. If the mass of the body will increase, momentum will also increase. If the mass will decrease, momentum will decrease. In the same way, if the velocity will increase, momentum will increase. If the velocity will decrease, momentum will decrease. So they are very directly proportional. Okay. So now let's start second law of motion. What is second law of motion? Turn the page. Yeah, okay. So on the page number 13, only on the top of the first topic, you will see Newton's second law of motion. So Newton's second law of motion gives the relationship between force and acceleration. The second law of motion states that the rate of change of momentum of an object is proportional to the applied unbalanced force in the direction of force. अभी क्या बोल रहा है कि सेकेंड लॉ ऑफ मोशन ये बोलता है कि कोई भी बॉडी को जब हम चेंज करते हैं उसकी मूवमेंट, उस चेंज मीन्स वी आर ट्राइंग टू मूव द बॉडी, राइट. So the rate of change of momentum of an object is proportional to applied unbalanced force in the direction of force. Okay. अभी क्या बोल रहा है कि मोमेंटम, रेट ऑफ चेंज ऑफ मोमेंटम भी होगा अगर हम बॉडी को डिफरेंटली अनबैलेंस फोर्स हमने पढ़ा था कि व्हाट इज अनबैलेंस फोर्स. Like from one side somebody is putting more force to move it, and some from another side it is putting less force to move it. So that is called unbalanced force. So जब भी body unbalanced force से move होता है तो that in that case what happen, momentum of the body will also change. The same thing is trying to say in the second law of motion. The rate of change of momentum of an object is proportional to applied force. So Newton's second law of motion can be expressed as force is directly proportional to change in momentum by time taken. Okay. Now suppose and mass of the object is m is moving along a straight line with an initial velocity u. It is uniformly accelerated to the velocity v in the time t by the application of constant force F throughout the time t. Okay, you will see double double it is written in, so ignore this single v f and t u, and just take the initial and the final momentum of an object is equal to p1 is equal to mu and p2 is equal to m. So v respectively. Now change in momentum would be p2 minus p1. अभी यहाँ पे क्या माना गया है कि फर्स्ट मोमेंटम जो है mu. Why I have written u? U is the initial velocity. Okay, p2 is mv, that is final velocity. So rate of change of momentum will be p2 minus p1, or we can write mv minus mv, or we can write mv minus u. Now when we have to rate, okay, जब भी हमें किसी चीज के रेट निकालना होता है कि रेट ऑफ चेंज ऑफ वेलोसिटी, रेट ऑफ चेंज ऑफ स्पीड, रेट ऑफ चेंज ऑफ मोमेंटम, रेट ऑफ चेंज ऑफ फोर्स, सो हमेशा हम उसको किसकी रिस्पेक्ट में चेंज कैलकुलेट करते हैं, रिस्पेक्ट ऑफ टाइम. So if we have to find rate of change of momentum, m into v minus u by t. Now force applied is proportional to the rate of change of momentum. So force is directly proportional to change in momentum by time taken. Force is equal to m into v minus u by t. This is the formula of this one, change in momentum. Okay, change in momentum. Force F is equal to km. Okay, so when you will solve this, na, you will get like this, km into v minus u by t. Okay. Now where a is equal to v minus u by t is the acceleration, which is rate of change of velocity. The quantity k is the constant of proportion. The unit of force is chosen in such a way that the value of constant k becomes 1. For this, 1 unit of force is defined as the amount that produces an acceleration of 1 meter per second square in an object of 1 kg mass. That is, 1 unit of force is equal to k into 1 kg into 1 meter per second square. Thus, the value of k becomes 1. The from equation of two, we don't have to understand, don't get confused from this. We directly proportional, when we will remove directly proportional, we used to put k, and k is nothing. Its value is just 1. Okay, so and we all know that force is equal to mass into acceleration in through the first law of motion. We know that force is equal to mass into acceleration. So the unit of force is kg meter per second square Newton, which has symbol. And the second law of motion gives us a method to measure the force acting on an object as a product of its mass and acceleration. Okay, so what is the rate of change? So you, and in this way you understood what is mass into acceleration. What is v minus u by t is a. We all know that in the previous, when we were studying about the equation of law of motion, v minus u is equal to t. So that's why I just removed it, m into a, m into a. So force is equal to mass into acceleration, and hence this Newton's second law is the same. Force is equal to mass into acceleration. Okay. So in this like next class we are going to discuss about the what is Newton's third law. So till the time, just keep revising all the points. Thank you. Bye bye. Take care.